Now we'll see a problem in quantum mechanics. It is regarding the raising operator in terms of angular momentum, and that will operate on the spherical harmonics with L is equal to m. And next we have to determine the value of the spherical harmonics with L is equal to m in terms of theta and phi. Then we have to find the value of normalization constant. Problem is, what is L plus acting on YLL? The second one is, use the result of the first one and put it together with L plus equation and the fact that LZ acting on YLL is equal to LH cross YLL to determine YLL theta and phi up to the normalization constant. Third one is, determine the normalization constant by direct integration. So L plus the raising operator operating on the function f Lm is equal to ALM FL m plus 1, and ALM is L into L plus 1 minus m into m plus 1 whole power half h cross. So if you use this formula, when you put L is equal m is equal to L, then the ALL is 0. So L plus acting on YLL is equal to 0. And next one is, you have to find out L, you have to use that LZ. So when LZ acting on YLL, it is LH cross YLL. It's already given. And so LZ is equal to, already you know, it is minus IH cross dou by dou phi in terms of theta and phi. So if you substitute this LZ, then it is minus IH cross dou YLL by dou phi is equal to LH cross YLL. So if you take y terms and phi terms, then if you integrate, then it is ln of YLL is equal to IL phi. So it is YLL is equal to C of theta e power IL phi. Here C is a constant, but it is in terms of phi, but it may depends on theta, so it's like put C of theta e power IL phi. And you know, it is L plus in terms of theta and phi is h cross e power I phi dou by dou theta plus I cot theta dou by dou phi. So if you use this, then the equation 2 becomes L plus acting on YLL is h cross e power I phi dou by dou theta plus I cot theta dou by dou phi C of theta e power IL phi. And already you know it, that value is equal to 0. L plus acting on YLL is equal to 0. So use that. Then if you integrate, if you differentiate, that is it is h cross e power I phi, then e power IL phi dou c theta by dou theta. And if you differentiate e power IL phi, it is you will get this IL. So it is already there is a plus I, so it is minus e power IL phi L into cot theta and C of theta, that is equal to 0. So if you simplify and make that C terms and other term, then you can get dou of C of theta divided by C of theta is equal to L cot theta is, we can write it as cos theta by sin theta dou theta. So if you integrate, it is ln of C of theta is equal to L ln of sin theta plus constant. And so C theta is A into sin power L. So if you substitute this in the YLM, then it is YLL is equal to A sin power L e power IL phi. Next is to find out the value of A. So for normalization, that is any function psi, if you take psi, it is psi star psi theta is equal to 1. So here it is YLL you have taken, so it is equal to A squared integral sin theta whole power 2L theta is equal to 1. And here it is y is a function of theta and phi. So it is, we have taken d tau in terms of theta and phi, that is sine theta sine theta d theta d phi. So it is a square integral from 0 to pi sine theta 2l sine theta d theta integral from 0 to 2 pi d phi is equal to 1. So integral from 0 to 2 pi d phi is equal to 2 pi. So it is 2 pi a squared integral from 0 to pi sine theta 2 par l sine theta d theta is equal to 1. And here now you have to integrate this. So this integral from 0 to pi sine theta 2l sine theta d theta, that sine square theta you can write it as 1 minus cos square theta. So it is integral from 0 to pi 1 minus cos square theta whole par l sine theta d theta. Now you take u as cos theta, so du is minus sine theta d theta. If theta is 0, u is 1. If theta is pi, u is minus 1. Because if theta is 0, cos 0, 1. So if theta is pi, cos pi is minus 1. So if you interchange this from theta to u, it is from integral from minus 1 to 1, 1 minus u squared whole power l du. And suppose if you take L is equal to 2, then it is 1 minus u squared whole square du. So integral from the limit minus 1 to plus 1. And 1 minus u squared whole squared is 1 plus u power 4 minus 2u squared. Now if you integrate and substitute the limit, we can get it is equal to 2 into 4 divided by 1 into 3 into 5. So if you, instead of L is equal to 2, if you put L is equal to L, then it will go like this, and it is integral from minus 1 to plus 1, 1 minus u squared whole power L du is 2 into 4 into etc. It will go up to 2L, and similarly the denominator 1, 3, 5 etc. up to 2L plus 1. And now you substitute this value in equation 9, then you can get it is 2 pi a squared into 2 into 4 into etc. up to 2L divided by 1, 3, 5 etc. up to 2L plus 1. That is equal to 1. Here, if you in the numerator, if you take 2 in all the cases, then you can get 2 per L terms. Uh, then other terms are 1, 3, 1, 2, 3 etc. up to L. And the denominator it is 1, 3, 5 etc. up to 2L plus 1. So the numerator is like 2 per L and L factorial. But in order to make the denominator as 2L plus 1 factorial, you are multiplying and divide by 2, 4, etc. up to 2L. So in now the denominator is 1, 2, 3, etc. up to 2L plus 1. So it is like 2L plus 1 factorial. So finally it is 2 pi a square 2 into 2 power L factorial whole power whole square divided by 2L plus 1 factorial, that is equal to 1. So if you simplify this, you can find A is equal to 1 by 2 power L plus 1 into L factorial into square root of 2L plus 1 factorial divided by pi. So if you substitute this in equation 7, then YLL is equal to 1 divided by 2 power L plus 1 L factorial square root of 2L plus 1 factorial divided by pi sine theta per L e power I L phi. Thank you.